this is going to be an action-packed 30 minutes, so I'm just going to get started. There are people going to be filtering in, but I'll tell them that they have to ask people who got here on time for the recap. So this is how to build more secure service brokers. If you meant to be in a different talk, you have about 30 seconds to awkwardly sneak out. Otherwise, buckle in. So my name is Denise. I currently work as a senior engineer at Pivotal. I actually currently work on the open source concourse team, so I'm not currently in service broker land. But previously, I spent 6 months being the product manager of the on-demand service broker SDK, which is a component that Pivotal builds to enable other service authors to rapidly build and deploy BOSH deployed services. I also spent 2 years working in service broker land between engineering on the BOSH core, on the Cloud Foundry Services API, and my first role at Pivotal was packaging RabbitMQ inside of BOSH releases and Pivotal Cloud Foundry tiles. So I've been in this world for a little while, and I sort of wrote this talk to be a resource. This is the resource that I wish I had last year, basically. So hopefully this is useful. All the slides will be published online. This is quite a content-dense slide, so don't worry about absorbing everything. My slides are already published on my website, and they'll be circulated afterwards. So that's my email, that's my Twitter, that's my website. All the art most of the art in this deck I drew. If it's like very enterprise-looking with boxes and lines, I probably didn't draw it. But if there's cats, I probably drew it. So we're going to start by level setting with a 500-foot view of what is a service broker and why you might need them. So I like to start with the problem statement when I answer questions like this. Product management, hashtag. So what problem do service brokers solve? So on the one hand, you have your application platforms like Cloud Foundry and Knative, maybe Kubernetes, and they're really great at managing the lifecycle of stateless applications. But the thing is, most applications need persistence data at some point or another, usually. So where do we get persistent services from after we run CF push or Knative build? I don't know. I don't actually know what the Knative CLI says. So in terms of like provisioning it, you can put service brokers in a number of places. Or sorry, you can put your persistent data services in a couple different places. You can host it yourself. You can template it using something like BOSH or Kubernetes or Ansible, or you can pay someone else to do it. You can consume software as a service from AWS, Firebase, Azure, DigitalOcean, totally like huge number of offerings out there, which sort of answers part of the question. That doesn't totally answer the question of how do we as application developers manage how and when our applications connect up to these persistent data services. So that's where service brokers come into play. A service broker is a component that enables application developers to provision new instances of a service for their application. And it's really important that this is a self-service model. Application developers have the freedom to define when they need it and configure their services however they need it. So what is a service instance? I've kind of been dropping this term, didn't really explain myself, so let me explain myself. So a service instance is one unit of a service that an application can connect to, and you can conceptualize them in a lot of different ways, and that's totally up to you as a service author. It's pretty open-ended. So a service instance might be as simple as just creating a new table in an existing database. Sounds kind of wonky, but you can totally do this. Or you can create a new user account in a service that supports multiple users, for example, a new MySQL user. Or you can create a totally new unit of work. Like you can spin up a new VM. Maybe you can spin up something on hardware. I think it's a little bit harder to do self-service on like bare metal without virtualization, but it is possible. There are a number of different ways to conceptualize service instances. This is a design decision that you get to make as a broker author, as a service author. So the challenge, of course, is that with so many different ways to conceptualize service instances, we are at risk for lots and lots of cobbled together APIs with diverging opinions. And that's sort of where the Open Service Broker API project comes in. So the Open Service Broker specification is an open source effort to standardize on the number of endpoints that application platforms will use to communicate with service brokers. So it's a specification that standardizes platform to broker HTTP-based communication using a simple set of API endpoints used to provision, gain access to, and manage service offerings. If you're new to the Open Service Broker API, I highly recommend just go on the website, check it out. It's very easy to consume, and they give really concrete examples for how you might use it. So at a high level, the APIs defined in the Open Service Broker spec govern instance lifecycle management. So this diagram is also, it's really blurry, sorry about that. This diagram, it's in higher definition on the Open Service Broker website. Definitely recommend you check it out. The final thing I want to say here is that service brokers are not necessarily a one-to-one relationship with platforms or not even necessarily a one-to-many relationship. They can actually be many-to-many. which means that you can have a bunch of service brokers provisioning instances for a bunch of different application platforms. The Google Cloud Service Broker is a really good example of this. You can have applications hosted in Kubernetes or Cloud Foundry, and they can all be pulling instances from the same broker, which is pretty cool. The only requirement is that they all speak the language of the Open Service Broker API. So the final thing I'll say here is that service brokers are really, really chatty. Like, they are extroverted. They really love to talk to the outside world, which is great for them, but it's difficult for us as people reasoning about security. So for example, you might ship your broker with an admin management console. They're probably going to be talking to something like CredHub or Vault for credentials management. They're probably going to be talking to some telemetry system, or maybe emitting logs, or push-pull, whatever it is. They might be talking to some underlying infrastructure. They're definitely going to be talking to the cloud platform at the very least, and their own service instances. So there's a lot of touch points here, and we're going to revisit this in a little bit when I'll give you some tools to make sense of securing brokers. So this talk is going to have three main parts, three main chapters. The first chapter is going to be about thinking about security in terms of the design and deployment of your broker. So the first question that I always try to ask myself is, what's the tenancy model of the underlying software that we're packaging? And I'm going to say this term underlying software a lot because as broker authors, it's kind of a funny term because you do have authorship and freedom to write code and design application logic to some extent, but you're a packaging layer if you're a broker author. You're packaging someone else's software, and that's really important to keep in mind. So is the underlying software designed for single or multiple tenants? Broadly, this is kind of a binary, but there's software that can be toggled one way or another. But broadly, things are either meant to be single tenant or multiple tenants. Let's explore what the different impacts are. So first, let's talk isolation. So when it comes to single tenancy, it means that you have one user account or one sort of service instance entity running on one VM or one box or one container, whatever that might be. With single tenancy, you have stronger isolation guarantees because this isolation is going to be both at the virtual level and perhaps also the hardware level. With multiple users, so if you have multi-tenancy, your isolation is going to be based on application logic, which puts you at higher risk for what we call the noisy neighbor problem. If one service instance, for example, has too many open connections, or if its CPU or memory fills up, it might impact other tenants on the same virtual machine or the same instance. So that could affect other people. So with a single tenant, though, isolation is stronger, but the disadvantage is that you're at higher risk of underutilization because once you provision this VM, it's just sitting there. Like maybe your application will use that much data, maybe it won't. Kind of hard to predict ahead of time. With multiple tenants, you can typically have higher utilization and more cost effectiveness because you can do like bin packing more effectively. And the final thing to think about is startup time. So if startup is important to you, then just remember that if you are going for a hardware-based isolation, typically you'll have cold starts it'll take longer to spin up a new instance. Versus multi-tenancy, when usually a new instance is just application logic, like a function call or an RPC call, whatever it is. So which model should you choose? And that's kind of a misleading question because really, as a broker author, you shouldn't choose this freely. You should choose this based on the design of the software that you're packaging. So you should try to align your service instance delivery models. So there are some products out there that really, really lend themselves to multi-tenancy. They've been battle tested as software as a service for many, many years, like MySQL. And if you're trying to package software like this, then by all means, go for it. It's pretty safe to ship these as multi-tenant offerings. But there's other software out there that's built with a strong trusted workload assumption that doesn't translate super well to multi-tenancy. So just know that if you go down the road of multi-tenancy with something that assumes that all workloads are trusted, you're going to have to put that much extra effort into your broker code, and that's extra code that you are going to have to maintain. When we're in the business of packaging software, I think that's not really the main thing that you want to be worrying about. So second question is, think about how and where your users, so where your platform operators that you are providing the service for, are going to actually deploy and run both the broker and the service instances. So this is like an infinite set. There are an infinite number of possibilities here, and I don't have time to cover, this could be a talk all on its own. But I'm just going to give you one example of security concerns that you might want to think about if you're deploying to Google Cloud Engine, Google Kubernetes Engine, GKE. So the question here is how will your operator host the service broker and instances? So This is a problem that my team discovered a few weeks ago because we have a multi-tenant offering that's deployed using a Helm chart over Google Cloud. And what we learned was that people were supposed to bring their own credentials, but one time someone forgot and they discovered, oh wait, there's another set of credentials right there. I can still spin up a cluster because every single cluster had the cluster admin credentials by default already loaded. That's how GKE is designed. It even says in the documentation, by default, nodes are given the compute engine default service account, which is like a huge set of permissions, which makes it super useful as someone developing using a GKE cluster. But if you're a service broker and you're trying to issue service instances over a GKE cluster, that's something that you want to think about. You probably want to take their advice, which is you should create and use a minimally privileged service account to run your GKE cluster instead of using the compute engine default service account. So what are we really driving at? So we're actually just driving at the principle of least privilege, which states that every program and every user of the system should operate with the least set of privileges necessary to complete the job. So this principle, the principle of least privilege, has been around since 1975, which is almost 50 years ago, which I think is pretty crazy. And I really like thinking about this because it's got a snappy name, so it's easy to remember. But it's also a great tool it's a great framework for turning into concrete internal security audit tools. So for example, you can write scripts that programmatically check file permissions on a given drive, and you can run these scripts as part of your regular unit testing workflows, which is something that I think quite a few teams at Pivotal do. So which brings us to the next chapter, service broker security in terms of easy wins and best practices. And this section is gonna be a bit of a grab bag. I apologize, it's gonna be a little bit scattered. But these are learnings that Pivotal R&D has accumulated over the last few years. So there's a concept that security engineers talk about called security in depth, or defense, it's actually defense in depth, but I like security in depth better. It means that your security provisions shouldn't all exist at the same layer. And it comes from the military principle that if you are protecting a fortress or whatever, then you should have diverse, multiple layers of security rather than just have a moat, or I don't know. That's how people defend forts, right? Build moats. So in software, what this means, if you're trying to protect against, say, SQL injection attacks, of course you should do things like you should sanitize inputs before they get written into the database. But if you're building a web app that is at risk for this kind of attack, perhaps you can leverage different types of security measures. You can also build your user-facing web UI to only permit certain characters and disallow special characters and things like that. So in this section, we're going to take a look at adding a few new tools to your toolbox to help you achieve security in depth. So first tip, basic auth is not auth. And there's a pepper there because this is the spiciest slide, even though it's not very spicy. So lots of teams leave basic auth in their service brokers. And while the Open Service Broker API says it's not okay, hang on. Yeah, it says it's something you can do, but you probably shouldn't. In fact, the Open Service Broker API recommends not supporting basic auth at all. So when should you use it? Well, basic auth is super convenient for testing and for development. So I think that's the case where it's really tempting to just leave it in so we can dog food the whole way. But I think we strongly recommend if you do use basic auth, if you're doing the software as a service model, just turn it off for production. Just don't even support that. If you're shipping artifacts, it's a little bit harder. One recommendation is perhaps you can design manifests and deployment tools to just have it off by default. So operators have to consciously think about why they're turning on basic auth. So the industry best practice these days is OAuth 2.0. Internally, our recommended implementation of that interface is to give every service instance its own UAA client. So of course, UAA is OAuth compliant and gives you a lot of functionality out of the box, so you don't have to re-implement all of it yourself. If you're working with Cloud Foundry, one recommendation is to check request permissions against the request maker's platform. Go back to Cloud Foundry. UAA would be unified across all of this, by the way. But you can still say, does this request came from a user, are they the right type of user? Are they in the right space? Are they in the right org? Are there any restrictions on whether this person should actually be able to make this request? Because just because all the requests should be coming from the platform doesn't mean they always are, they can be spoofed. So this is just an extra layer of security that you can perform. Of course, don't share your UAA clients. If you're sharing UAA clients, that pretty much negates all the security benefits you get from using UAA. In terms of sending back response headers from your broker, our recommendation is to follow RFC 6750 and I didn't put it here because it's super long and technical, but this is a set of guidelines for sending back request headers that are meaningful but not leaky. And finally, there was a couple of CVEs in the last few years where people figured out that when you were spoofing request headers, you can just say that token validation method, none, and then token validation wouldn't occur. So that's not great. If you're sending tokens, you probably want them to be checked, so make sure you explicitly turn off none as an option. So of course, like with sanitizing user inputs, this is a huge category of security vectors, and there's a lot to say about it. But generally, just be very skeptical of all user input. Assume that your users are bad. Assume that they're going to put special characters and try to SQL inject you. If you're packaging your broker, for example, with the dashboard with text inputs, just be really careful about what's happening to that text further downstream. And also be careful of special characters that can break your runtime in ways that might like bubble up, I don't know, like Maven errors. I don't know Java super well, but like your build tooling, like sometimes when I know like in Go, it'll like dump a stack trace, so just be careful of showing stack traces when you don't mean to. For service brokers more specifically, one thing we should think about is arbitrary configuration parameters. So when you run CF create service, you give the service offering name, and then the plan name, and then the name of your new instance. You can do -C to send some additional parameters. As a service broker, you can provide a JSON schema to whitelist only certain keys and value types. But even if you don't do that, or even if you do, you still are going to be taking strings probably at some point or another. So just be careful about what happens to those strings. They're not going to dox like Cloud Controller or anything, because Cloud Controller stores them as string safe JSON. So as a broker author, like this is something that you should think about, like how are we handling those strings, how are we forwarding them? And finally, URI parameters. So this is a real CVE from 3 years ago, where someone figured out that if you access the Logaggregator API and you put JavaScript at the end of the URL, that it would actually execute it in like the client-side browser, which meant that you could totally just steal someone else's cookies and the contents of their local storage, which seems really, really bad. It is really, really bad. So just be careful about this. Another category of security measures is to always use encryption for data that's in flight and at rest. For in flight, our standard recommendation is use TLS for process-to-process communication. Even if they're living on the same box, it's still good to default to encrypted communication everywhere, like all the way down the stack. Of course, perform hostname verification. Don't just say like, yeah, like from whoever. That kind of undercuts your security like effectiveness. And with proxies, I've only seen this a few times, but if you have to use proxies for local unencrypted channels, only have like one proxy per local host to give yourself maximum auditability and reduce the attack surface area. But it's better to just use encrypted channels if you can. In terms of at-rest encryption, this is a little more dependent on the tools that you're using, but most modern databases, almost every single open source database out there offers at-rest encryption options. So I would say just like do your research or just choose one. It's going to be better than none. If you're a broker author and not the person who's going to be deploying the broker, you could also think about offering recommendations for hardware-based encryption. Though this is especially important to think about, I think, if you or your customers work in a domain where data protection laws are part of your legal compliance obligations, like if you're working with healthcare industry and you have to follow HIPAA, there are pretty strong regulations around that. So when it comes to service binding secrets management, service bindings are the credentials that applications use to connect to an instance of a service. It's unavoidable to have these credentials in the runtime. You just like can't really get around that, otherwise your Rails application doesn't know how to connect to your database. But beyond that, there are a lot of places that you could actually cut out having to store them in plain text. Generally, as a rule, they should never be persisted in plain text if you can. So what you can do is you can, so basically, like you can almost think of brokers as the biggest piece of middleware ever between like requests from the application platform to your instances. So like when application platforms make a request to the instance, that request is going to be going all the way through your broker code, and you can add code to translate to do variable resolution, so that on either side, you're just reasoning about things in terms of like, double parentheses, escaped names, or paths to CredHub, or paths to vault secrets, and things like that. But the broker should do variable resolution so that users never have to copy and paste a plain text secret, hopefully. So something else to be aware of is the side effects of service bindings. So when you create a service binding, it's not only issuing a set of credentials, there are often other side effects. So when you unbind or when you delete a service binding or you delete a service key, it's really important to be vigilant about what artifacts are you leaving behind. Like, did you create any database connections? It would be bad to keep database connections open forever. Like, your pool's eventually going to fill up, but also it's just like bad practice. It's a common practice to create temporary users and groups, files, directories, mounts. Make sure those get cleaned up when the binding is deleted. Make sure that you don't leave credentials and configuration files behind on disk. And make sure that you're going back out to any external like blob stores or object stores, like credential stores, when that service binding gets cleaned up. So one of the easiest mistakes that I see teams make is accidentally publishing credentials to GitHub repos, or even worse, like packaging them inside Docker images and then publishing them. So don't do that. We use a CLI called credalert that automatically scans every file in the directory recursively and yells if it finds any string that looks like a certificate or a secret key. There are other tools out there. This just happens to be the one that we use internally, but this is open source, so you can start using it as well if you want. What we do is we actually run the credalert CLI as part of our Git commit hooks. So developers don't even have to think about it. This just automatically happens. I would say generally, if you can find these sort of like easy wins that fit into your existing development workflows and promote security best practices, that's the best way to build security awareness. Like things that you do for free, like you should just do. So the final two things I'll talk about in terms of BOSH and Cloud Foundry are if you are using BOSH to manage the broker or the instances, BOSH processes are currently not containerized. So the next best thing that we can offer is a BOSH release called BOSH Process Manager, BPM. It offers some security improvements by wrapping every process that Monit knows about in its own namespace. So it doesn't implement the other Linux primitives that you would get with containers like C groups or file system capabilities, but it's better than nothing. It means that your processes at least can't see each other. They can still have side effects that interfere with each other. But this is at least a first step towards better security, better inter-process security for BOSH-managed service brokers. And final thing is, so as of last year, Cloud Foundry gives you the option to share or not share service instances. To share a service instance means to allow a user in a different space to connect to your service instance, but you have to share it to them first. So this introduces, like, I remember like when I was on this team when we developed this feature, and we actually did a lot of brainstorming around like what are all the possible abuse vectors that people could use, like now that they can share, they can read and write to other people's, like message queues, other people's databases. So this just adds a whole new level of things to consider if you're a service broker author and you're considering implementing this feature. It is worth calling out though, like if you're worried about the risk of this, one way to mitigate that risk is to detect where the service binding request is coming from, and if it's coming from an outside space, like a space that has been shared to, you can demote the permissions on those bindings. You can make other people read-only, for example. So the third and final chapter is going to be around processes and practices. This is going to be a little bit less specific to broker security, but I think it's the most important because all those recommendations and easy wins are great, and like maybe you can turn some of them into backlog stories next week, but they're only as good as like our current knowledge, right? Like security is ever evolving, and if we're not building a culture where we're constantly growing, constantly evolving this security-minded conversation, we're gonna stand still, and attackers will get ahead. So I'm gonna cover two things in this section. First, I'm gonna talk quickly and generally about continuous delivery. So what is continuous delivery? It's a set of practices that promotes getting your changes in front of your users as quickly as possible, but also in a way that's safe and sustainable. So the two great books to read about this are the book titled Continuous Delivery by Jez Humble and Dave Farley, and also Accelerate by Dr. Nicole Forsgren is a great like data-driven analysis connecting continuous delivery practices to business outcomes and risk reduction. So highly recommend checking out both of those. But one way to reduce this sort of time to market is by automating all the boring, not the boring stuff, by automating the toilsome stuff. So things like testing and deployment and release processes. If you can have a pipeline do it, have your pipeline do it. Don't have humans do it. And finally, build and deploy constantly, like frequently, and also in small batches, because the goal here is to have your emergency patches, those like stressful CVE weeks, like when a Linux, like security vulnerability is disclosed, have the cycle time of that emergency patch be the same as your normal release cadence. So I really want to emphasize this again. Like, if you take nothing else away from this talk, please remember this. Invest in your release engineering process. If you're authoring service brokers, you're most likely going to be shipping artifacts, and it's going to take your customers time to perform upgrades. And in recent history, some of the most catastrophic security incidents have been related to vulnerability exploits, have been on the order of days, not weeks. So the best way to stay on your feet is to build processes within your engineering team that already optimize for short cycle times, so that those scary CVE weeks are just normal weeks for your teams. So the final thing I'm going to talk about is building a sustainable culture around security, because again, security is an ever-evolving set of practices. Without a culture where learning can continue, again, those simple fixes and easy wins don't really matter. So the first thing to think about is, how do you grow a healthy security-minded culture? And I think the most important thing here is psychological safety. And that's really, really important for security, because if people are scared that if their software needs a security patch and they're going to get in trouble for having shipped vulnerable software, then you're going to build a culture based on fear and bureaucracy. And I don't think that's super conducive to security awareness. So how do you start building this culture? I'm going to offer a few concrete steps, but this is more like a reflection of what we've done internally, the security triage team, Molly's team, rather than a playbook. So this is anecdotal. Don't be Denise told me to do this, therefore we're going to do this in our organization. But what we did was we made it easy we identified that one problem was that people didn't know who to turn to when they had security questions. So make it super easy to find the right people. Set up a mailing list like security at whatever your organization is. If this mailing list is properly socialized and people know about it, then probably you're going to get a lot of emails. Form a team to triage these emails and make decisions around what are the most important security, maybe shared tooling to build, and also to iterate on what it is they're supposed to do. And then develop and socialize processes like workshops. Iterate on different workshops, and do it with a train-the-trainer mindset, though, because you're probably going to have a pretty small team. That team can't teach all of your internal teams everything. So enablement building is pretty much the name of this game. If you want to learn more about this, I highly recommend you watch Molly's talk from SpringOne 2 years ago called Healthy Agile Security Culture, which digs into this story in much more depth. So the final thing I'm going to talk about is, as part of ongoing security education, another tool in your toolbox to consider using is to run periodic threat modeling workshops with teams who are authoring brokers. So one model is Stride, which is developed by Microsoft. It's a mnemonic that stands for those 6 letters. You can read. I'm not going to read them out loud. So the goal of a threat modeling workshop is to help the entire team build a mental model around security concerns in a specific part of your system. So how do you run a workshop? Well, this is how I've seen it done before. I'm sure there are different ways to do it. But in step 1, the team needs to agree on the scope of the experiment. So agree on a part of your agree on a part of your system, agree on the architecture of it, maybe have everyone draw it out and then converge on a model, and then have one person come up with a clean and high fidelity visualization that you can use for the exercise. Review what each of the letters mean so you can level set for your team. If you've never run a Stride threat modeling workshop before, this talk by Adam Shosak and Microsoft pretty much tells you how to do it. So you can just watch that talk as a team. And finally, you can do this part in a couple different ways. The way that we've done it internally is we have everyone just take Post-it notes and we say, all right, we're going to talk about spoofing. Everyone grabs a Post-it note and writes down scenarios related to spoofing that they think an attacker could use to attack our system. Once you have a lot of different ideas, you can sort of prioritize, figure out a few that are common and high priority to talk about, and then you can turn those into action items if there's a clear path to remediation. Otherwise, just file it away as something that we're going to continue to improve and continue to learn about. Also, there are a lot of people who really love to gamify the Stride threat model for some reason, so you can actually download playing cards that have pre-made, generated specific scenarios, and that say things like, oh, an attacker can change the request header to spoof their identity and then send a request to our system. So when you have these specific scenarios, you can actually sort of play them like poker and say I think that this is the biggest threat to our system, and someone else can be like, no, I don't know, this, the other thing is the biggest threat. I don't know. It's kind of silly, but it's also kind of fun. So to summarize, what we talked about today was the design and deployment of brokers with security in mind, a number of different easy wins, kind of a laundry list that you can implement today or in the near term, and finally, how to think about building a security-minded culture in order to keep learning and growing, because all of these specific recommendations are not gonna stand the test of time. However, if you grow the capability to reason about security, that's going to be a much more robust and much more long-term way to think about this. Thank you to these people for their help on this talk, and thank you so much for your time. If you're interested in the slides, you can access them right now on my website. Otherwise, you can wait for the official slide share out from the SpringOne organizers. Thank you.